With Elon Musk saying that he is highly confident that we could see a human on Mars by 2026, that means we can see Mars colonization in the near future. So let's talk about it. In my last video, I covered a more hypothetical concept on how we could colonize Mars. Today, I'm going to be focusing on how we can colonize Mars using the resources we have now and in situ resources. So let's back up. Let's first cover what in situ means, which basically is talking about using resources local to Mars. So instead of shipping out supplies to Mars, which can often be costly, granted how expensive space travel is, we would actually take resources from Mars and use that to build our colony. So let's treat this Mars colonization kind of like camping. We're going to need some shelter, we're going to need some food, water, and instead of fire, we're going to need oxygen, and that can act as our oxidizer, which can create fire, but also helps us breathe and stay alive. There's two ways how we can approach making a shelter or our camp in this case. And that can be either going down the route of concrete or ice. And I'm not talking Elsa's castle, ice castle, all that. I'm talking actually using ice to build a home. Both concrete and ice have a special property that protects our homes from radiation, and due to Mars's lack of a magnetosphere, there's going to be a lot of radiation that we're going to need to deal with. Therefore, there's going to be need for protection. That's why we can utilize either ice or concrete to protect us. For a possible concrete house, we can utilize the resources local to Mars to make the concrete. So we can use Mars's soil, which is also called regolith, and sulfur that we can find on Mars. And this 50% regolith and 50% sulfur can be combined to create concrete. And our concrete will be binded using plaster Paris, which is made out of also sulfur materials local to Mars, such as gypsum or basanite, to bind the concrete together. We would then use a 3D printer to 3D print a shell design, which would act as our house. The interior will be pressurized to allow the astronauts or the people living within the house to walk around in no unique clothing and just be able to chill. Another option we can use for building our Mars homes is ice, and that's because it provides several benefits, such as it being able to transmit light, which can actually be helpful towards mental health. Our ice homes are going to be made out of ice that we extract from one of Mars's craters. Mars is filled with ice due to recent studies showing, so we can use a robot attached with a laser that can cut out the ice, and then later we take that ice and we purify it by melting it and removing all the impurities. Therefore, we won't have any bubbles when we try to 3D print this ice. So I just hinted at it, and we're going to actually 3D print this ice out into our homes using thin layers. But to kind of back up, in the ice, when we are extracting the impurities, we're going to actually add some more material to strengthen the strength of this ice. We're going to actually add in a material to increase the strength of the ice by 3x. And that is going to be called, and that material is called picrete, and it's a type of wood pulp. So we're going to add that into the ice and then 3D print it out. And we're going to 3D print it out into layers to avoid the brittleness of ice, as it does not have that great tension. It's a brittle material, so it's not going to have very great tensile strength. Once we 3D print our ice structures, we're then going to go back in and add an aerogel to insulate the heat in our ice homes, as ice is pretty cold. And this aerogel will allow light to transmit through, and it will be 66% translucent while keeping the heat inside. NASA has a paper published where it shows a concept of what an ice home might look like, and it includes a pressurized environment and this ice bubble. It's basically called an isome, and it has a greenhouse, libraries, workspaces. It's actually really pretty, and part of me just gets the hype that I really want to live in Mars now. So I'm going to include some pictures to show just how cool it looks. So let's move on to the next step of preparing for our camping trip to Mars, and that is water. So how exactly are we going to get water on Mars? And instead of wasting a lot of money trying to transport water over, and it's just going to be such a complicated and messy process, we can actually utilize the ice that is on Mars and turn that into our water. We can utilize a process called basal melting, and this occurs naturally in ice glaciers, where the bottom of the ice glacier melts while the top remains frozen. So basically that's what we're going to try to do with the ice glaciers on Mars. We're going to utilize salt and geothermal heat flux. So let's cover what those mean next. Geothermal heat flux is the heat flow underneath Mars's surface. So that can be from volcanic chambers, magma chambers, all that. Our magma chamber will be placed 10 kilometers below the ice glacier that we're trying to melt, and therefore causing this ice to melt and become water. We are going to locate this magma chamber based off of the subvolcanic activity that has previously been shown in Mars, and therefore we get water. And of course this water will still have to be filtered and go through a bunch of processes before we can actually drink it, but then we basically got water, which is what we need to survive. Next, let's move on to food. So we're gonna need some food to eat in order to survive. That's just a kind of known fact. And unfortunately, Mars does not really have any Chipotles nearby that we can just grab some food. So we're gonna have to grow our own crops. In order to grow our crops on Mars, we are gonna need nitrogen, as it's one of the main nutrients that plants require in order to grow. That nitrogen helps the plant in photosynthesis and helps it produce the energy it needs to survive. But unfortunately, Mars's soil lacks that nitrogen that we need to grow our plants, as hinted by its surroundings and pictures on Mars. You can see it's more of a desert-like set, so it's not ideal for growing. But that Mars's soil does have carbon, which plants do use to create energy, which is helpful. But this can bring around two big questions. One, is it even possible to grow plants on Mars's soil? And two, if possible, how do we get that nitrogen into the soil to grow the plants? And yes, it does. We can grow plants on Mars's soil. In a recent study, they tried to simulate Mars's soil, and they compared it to a simulation of the lunar soil and a simulation, well, not really a simulation, an actual Earth soil, but it was nutrient poor. And they actually were able to grow plants on Mars, and they found that actually the most plant growth was in the Mars stimulant soil, which actually does prove a plus in terms of growing crops. Now, to answer the second question of how do we get that nitrogen into Mars's soil, we can use plants called nitrogen fixators, which basically, by growing those plants, they put nitrogen in our soil, so therefore making it easier to grow other crops in that soil. Now that brings in questions of, can it grow in Mars's temperature? Can it grow with the Mars's water, air conditions, all that? And to answer that, we don't know much. But if we can create a greenhouse environment in our Mars's homes, then we don't have to deal with those issues. An alternative to growing plants in soil is just eliminating the soil part and using hydroponic farming, where we grow plants in nutrient-rich water. Okay, now we're going to go into oxygen, which is going to be specific for our Mars camping trip. Although in some cases, it can also be our oxidizer fuel. But the main use of oxygen in our colony will be in order to breathe and survive. Unfortunately, on Mars, we don't have oxygen as readily available as we do on Earth. But fortunately, Mars's atmosphere is made out of 99% carbon dioxide. So we can take the CO2 and extract the O2 from it to create oxygen. So I'm not going to go super in depth with the process because I go into the process in my article and I'll actually link it down below. But basically NASA has this machine experiment that they're doing called the Thermodynamic Model of Mars Oxygen in situ. So remember that is in Mars, like local to Mars resources experimentation. And basically they're utilizing a process called solid oxide electrolysis to produce oxygen. We're going to cover one of the main components of NASA's machine, which is the SOXE. So that's the solid oxide electrolysis experimentation. And we're going to cover exactly how that works. You might recognize the word electrolysis because that's the process that jewelry makers use to gold plate items. Except in this case, we're going to remove the water out of this component and add an electrolyte that is filled with negatively charged electrons throughout it. So the CO2 molecule will go through the porous cathode, and the negative charge causes the O2 to separate from the CO2, and it becomes negatively charged. So this positively charged C now just stays up there, while the O2, negatively charged, it's attracted to positive charged items. So it flows through the electrolyte and it's allowed to move freely because the electrolyte is full of electrons throughout it, and free electrons. And it flows through that electrolyte to the anode, and the anode is positively charged. So it'll remove this negative charge from the oxygen and it'll send it back to the cathode while letting the oxygen flow through down and then getting released. While the C, the carbon monoxide now, is held and released as a byproduct. Okay, so now we're done packing for our Mars camping trip. Now we can head off and go to Mars. But that will still require some building of how to build rockets or transport devices to get us to Mars. And check out my other video where I actually explain an ion thruster and I go in depth of how we can use that to go to Mars.